So again, I'm recording. Please feel free to stop me if you need to. Now, even though this worksheet right here says solve by using the quadratic formula, I wouldn't use the quadratic formula unless it's not factorable, right? If it's factorable and you could easily factor it, you might as well do so. Even before using the quadratic formula, you need to make sure that it's equal to 0. And whenever you do have a quadratic trinomial with no number in the front, you might be able to do this, parenthesis, 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 x, x, and then you think, what times what is the c value that if you combine together is the b value? You might have to make a list. How could you get negative 20 with multiplication? It could be negative 1 times 20, or negative 2 times 10, negative 3 times nothing, negative 4 times 5. Those are all the possible ways of multiplying numbers together to give you negative 20. Which of these pair of numbers combines together to give you the middle value, which happens to be negative 1? Well, if I combine the negative 4 and 5, that'll give us a positive 1. And we do want a 1, but we want it to be a negative 1, not a positive 1, which means we have the right numbers, just the wrong signs. So you just change that to a positive 4 and that to a negative 5. And voila, you have factored. Just put the plus 4 right there and the minus 5 right there, and you have factored. Now, why would you want it in factored form? Because it's still equal to 0, and you could now use zero product property. What does that mean? That means that if you have something times something and it equals 0, the first something, x plus 4, that could equal 0, and the second something, x minus 5, that could also equal 0. And if you solve both of them, you're going to get your two answers, x equals negative 4 and x equals positive 5. Super easy, right? You could have, if you wanted to, identified A being 1, B being negative 1, and C being negative 20, and use the quadratic formula, but that would take way longer, so it's way faster to factor, split, and solve. So let's use the skills that we learned back in Chapter 8 of factoring, splitting, and solving whenever we could use them. So we move on to this one right here. Again, it's equal to 0. That's great. There's no number in the front, so that means I would like you to try to factor it. So set up your binomial times binomial with the x right there and the x right there. Of course, it's still going to equal 0. If I can't factor it, then I'm going to do the quadratic formula. But right here, when you think what times what is 30, that if you combine together is the b value 11, go ahead and make a list of the multiples of 30. That could be 1 times 30, 2 times 15, 3 times 10, 4 times doesn't work, 5 times 6. Those are all the pair of numbers, different pairs of numbers that I can multiply together to give me 30. And which of those pair of numbers, when I combine them, gives us the middle value, positive 11? Be 5 and 6. Perfect. And you don't even have to change any signs. That's just a positive 5 and a positive 6. And now you could do zero product property, which says if you have something times something and it equals 0, well, the first something, the x plus 5, that could equal 0. And the second something, the x plus 6, that could also equal 0. And if you solve both of those simple one-step equations, you're going to get x equals negative 5 and x equals negative 6. Those are your two answers. Solved really quickly, really easily, using the skills that we already learned in Chapter 8 of factoring, splitting, and solving. Another way you could double check your answers on this worksheet is to go to Desmos and type in y equals x squared plus 11x plus 30. And you will see that it's opening up with the pattern 1, 1, 2, 4, 3, 9, and it crosses the x-axis at negative 5 and negative 6. And those are your solutions. The x-intercepts are the solutions. Anyway, like I said, this worksheet, it says use the quadratic formula to solve, and we haven't even used it yet because whenever it's factorable, you might as well factor because it's so easy. Let's look at number 6. Again, even before factoring or even before using the quadratic formula or even before graphing with Desmos, you want to make sure that it's equal to 0. So go ahead and add 1 to both sides. That way it could equal 0. You're going to have x squared plus 4x minus 1 equals 0. And now you could try to factor, thinking what times what is negative 1, that if you add together is positive 4, but that's not going to be factorable. So even though there's no number in the front, it's not factorable. You have to rely on the quadratic formula, okay? So when you use the quadratic formula, I recommend writing it down. It's x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And when you use this formula, I recommend rewriting it, but with parentheses, negative parenthesis, plus or minus the square root of parentheses squared minus 4 times parentheses, all divided by 2 times parentheses. And then you could safely identify your A value, which is 1, your B value, which is positive 4, and your C value, which is negative 11. So let's start with the B values here and here, which is 4 that we're plugging in. We're plugging in 4 into the first two parentheses, a 4 right there and a 4 right there. Then you're plugging in the value of A, which is 1 right there. So you put a 1 right there and down here. And last but not least, we plug in the C value of negative 10, or negative 1 right there. I'm sorry, negative 1. Now, once you have it all plugged in safely with parentheses, you start with the discriminant. By the way, guys, if you wanted to, you could type in the entire square root on the calculator. You could open up the square root, open up parentheses, 4, close parentheses, squared, minus 4, open parentheses, type it in exactly the way it is, and you'll get an actual number here. That way, when you get to this part, you have a negative 4 plus or minus divided by 2 times 1 is 2, and whatever number you get there, you're going to be able to add it and then subtract it and get your two answers. So you could type this all into the calculator, all right? I'm going to do this by hand. Obviously, working with the discriminant first, you're going to do the exponent first of the discriminant. So when you go negative 4 times itself, 4 squared, that's 4 times 4, that's 16. And then you have a minus 4 times 1, that's a minus 4 times minus 1, that's a plus 4. So you end up with 16 plus 4, which is 20. Now that is the discriminant, the value that should belong in here inside the square root. So in reality, you're going to have the square root of 20, not the square root of all this junk. So that's what I'm going to write down here, the square root of 20. And then from here, you use your calculator to actually figure out what the square root of 20 is. If you do it on the calculator, it will give you, square root of 20 on the calculator will give you 2 square root of 5. Now, I didn't use a calculator. I know that if you don't have a perfect square number, you want to rewrite it with multiplication to get a perfect square number. Then you could split the root and you could actually do the square root of 4, which is 2, and the square root of 5 is there. Again, you could use a calculator, type in square root of 20, and it'll give you 2 square root of 5. Now, what does that mean? That means that you could now rewrite it as negative 4 plus or minus 2 square root of 5, all divided by 2, okay? And this is your answer. However, it's very important that you know how to reduce your answer, because if this were the final exam, which is a multiple choice test, this will not be on your multiple choices. What you need to do is recognize that 4, 2, and 2, they're all divisible by what? By 2. So you need to divide them all by 2. Negative 4 divided by 2 is negative 2. 2 divided by 2 is a 1, which you don't even need to write. And 2 divided by 2 is 1, which you don't need to write. In other words, this is what I have, negative 2 plus or minus. I'm going to write the 1 just for funsies' sake right here. And then divided by 1. Now, obviously, we don't need a 1 right here, and we don't need the divided by 1. That makes no sense. So what you're going to see on the multiple choice answers, if this were on the final exam, negative 2 plus or minus square root of 5. That's it. Okay? Let's try another. Okay, so this is equal to 0. You need it equal to 0 no matter what, even if you're trying to factor. This is not factorable. You can't think what times what is 3 that gives you 6. When you add it, it doesn't work. So you need to use the quadratic formula. And when you use the quadratic formula, I would like you to replace the letters with parentheses. That way you could easily plug in your B values, which are 6 right here and right here, your A value, which is 1 right there, and your C value, which is 3 right there. And of course, you're going to begin with the discriminant, and inside the square root, the discriminant, you begin with the 6 to the second power. 6 times 6 is 36. And then you have a minus 4 times 1, that's minus 4. And then minus 4 times 3 is a minus 12. So you really have 36 take away 12, and that is 24. So that is your discriminant value, the value inside the square root. Now we could rewrite it, but instead of negative parentheses 6, I'm just going to write down negative 6 plus or minus square root of, and instead of all that junk, I'm going to put 24 because that's what it equaled. And it's over 2 times 1, which is 2. Okay, now at this point, you need to be able to simplify the square root of 24. If you forgot how to do that, just get a calculator, type in square root of 24, hit equal, and it'll give you the simplified radical. That will be 2 square root of 6. Just in case you wanted to learn how to do that by hand, 24 is not a perfect square number, so you rewrite it so you could get a perfect square number, 4 times 6. And then you split the root, and you could actually do the square root of 4, which is 2, and the square root of 6 stays. So we're going to replace the square root of 24 with 2 square root of 6. So here we go. We have negative 6 plus or minus 2 square root of 6, all divided by 2. And once again, this is the correct answer, but it's a fraction that's not simplified. You have to reduce it. You have to recognize that there's 3 terms right here, and they're all 3 divisible by 2. So if you reduce by 2, that'll be a negative 3. Reduce by 2, that'll be a 1. Reduce by 2, it'll be a 1. So you really have negative 3 plus or minus square root of 6, and that's it. Now, if you're thinking, wait a minute, what happened to the 1 down here? Remember, divided by 1, it's not necessary. If you're working on a problem and you get 7 divided by 1, you're just going to write 7. You're not going to write it as 7 over 1. So you don't need the over 1. And the 1 right here in front of the 6, in front of the square root of 6, you don't need it. So don't write it. And that'll be what you'll find on the multiple choice if this were on the final exam. This is the last one we're going to do here in class. Again, no matter what you want to use to solve this, whether it's factoring, whether it's a quadratic formula, or even if you wanted to graph it on Desmos so you could see the x-intercepts, which are the answers, you still need to set it equal to 0 first. So subtract 9, rewrite the whole thing. You're going to have a 2x squared plus 7x minus 9 equaling 0. Now that it's equal to 0, you could identify your a value of 2, your b value of 7, and your c value of negative 9. Okay? So that means we could safely plug it into the quadratic formula. But of course, when you plug it into the quadratic formula, you should rewrite it with parentheses. That way you could easily plug in the b value of 7 right here and there. So we're going to put the 7 right in there. The a value is 2. We're going to put that right there and down here. So 2 right there, 2 right there. And the c value of negative 9, we're going to put that right there, negative 9. And of course, we're going to do the math here of the inside of the square root, which we know is called the discriminant. So when you do the discriminant, you're going to begin with the 7 squared. 7 times 7 is 49. I just write that on the side. Then I have a minus 4 times 2. That's a minus 8. But then minus 8 times minus 9, that's a positive 72. So what we really have is 49 plus 72, which ends up being 121, I believe. So the discriminant is 121, which is pretty awesome because that's a perfect square number. So what does that mean? I could replace all this junk with 121. So instead of writing negative parentheses 7, I'm just going to write negative 7 plus or minus the square root. But instead of all this junk, I'm going to write 121. And it's over 2 times 2, which is 4. Now, at this point, you need to do the square root of 121. And if you know that 121 is a perfect square number, you'll know that that equals 11. If you don't know that, just use a calculator and it'll give you 11. So what we really have here is negative 7 plus or minus 11 divided by 4. Now, the plus or minus actually produces 2 answers. You're going to do negative 7 plus 11 divided by 4, and then negative 7 minus 11 divided by 4. I always draw 2 arrows, negative 7 with the plus 11 divided by 4, then another one, negative 7 minus 11 divided by 4. So on the top one, negative 7 plus 11, that is 4, and 4 divided by 4, the answer is 1, okay? Now on the bottom, we have negative 7 minus 11, that's negative 18, and that's going to be divided by 4, and 18 divided by 4 doesn't work, but you could at least reduce it. You could reduce both top and bottom by 2, giving you a negative 9 over 2. And negative 9 over 2, that actually equals negative 4.5 or negative 4.5, right? So those are your 2 answers, positive 1 and negative 4.5. What does that mean? That means that if you were to have graphed on Desmos y equals 2x squared plus 7x minus 9, it'll be a parabola that opens up, and it would cross the x-axis at positive 1 on the x and at negative 4.5 on the x, in between negative 4 and negative 5. So I recommend using Desmos to double check your answers. And I really need you guys to practice this quadratic formula. Okay, number 11 is an interesting question because on the solutions, it says that there is no solution. But I actually pulled a question like this from my Algebra 2 class. And in Algebra 2, you actually have to state the specific answer, even if it's imaginary. So let me just go through this step by step with you guys. Of course, we're going to identify the A value is 2, the B value is 5, and the C value is 4. And we're going to use a quadratic formula. X equals negative B plus or minus the square root of B squared minus 4AC all divided by 2 times A. And of course, when you use this, please replace the B, the A, and the C with parentheses. And then you're going to begin by plugging in your B value of 5 right there and right there. So 5 and 5. The A value is 2. Plug that in right there and right there. And the C value is 4. So you plug that in right there. Now doing the math, doing the discriminant math, you're going to begin with 5 squared, that's 25. Minus 4 times 2 is 8, or minus 8. And minus 8 times minus 4 is minus 32. So if you do 25 take away 32, you're going to end up with a negative 7. So the discriminant is negative 7. Let me rewrite what I have so far. Negative 5 plus or minus the square root of negative 7. That's what the discriminant was. And it's still over 2 times 2, which is 4. Now, at this point, in Algebra 1, we know that the square root of a negative doesn't work, right? If you try to do square root of a negative on the calculator, it'll say error. That's because it's imaginary. So at this point in Algebra 1, you could say no solution, right? There is no real answer. This parabola will not cross the x-axis. However, there are 2 questions that are very similar to this on the practice quiz, and I actually go through and finish it the way an Algebra 2 class would. If you have a negative on the inside, all you got to do is pull it out and make it an I, okay? So the negative that was inside with the 7, you pull it out and make it an I. So you're going to now have negative 5 plus or minus with an I out here, and then the square root of negative 7 is now just a regular positive 7 over 4. And that would be your final answer on that practice quiz, right? In Algebra 1, if you have a negative, you just say, oh, no solution, that's it. But there's a couple of questions where I pulled from the Algebra 2 class where you actually have to show that that negative comes out as an I. And like always, if for some reason, like you had a 5, a 10I, and a 20, you could divide all of them by 5. You reduce them if possible. But again, if you have a negative in there and you try it on the calculator, it's going to say error. Make sure you pull out that negative, make it an I out here, then try to do this on the calculator. And yeah, that's it. All right.